Okay. Hello, good morning, good evening, I guess, wherever you are. Don't want to be exclusive. But yeah, hi everybody. I'm Emily. I lead the DevRel team here at Scroll. I'm here to bring on Kevin to talk about, take us through a coding workshop. So before I butcher my words in the future again, Kevin, please introduce yourself.
Hey everyone, I'm Kevin. I am the software guy at Anyrand. Actually, we're the Frogworks team. We work on Anyrand. We also work on other stuff such as Loto PGF, if you've heard of that, and soon to be AutoDAO, which is exciting. I used to be an embedded systems engineer, and then a bit of a web dev, and then now I am really obsessed with cryptography and all things to do with that, like ZKPs, and especially randomness. Yeah,
Yeah.
so that's a little bit about me.
Wild. I love frogs. I remember when you talked about frog, or like when Frogworks was still mentioned, I was like, whoa, where did that name come from? How is this decided? Um,
Yeah, we
but
love frogs. I
perfect.
see T likes frogs in general, right?
Oh, crypto Twitter?
Yeah,
True,
yeah.
true. I think the thing that I always said was like, no one, who's into real frogs? Because Pepe, I think, is like a different kind of beast than like a white tree frog or a desert rain frog. I'm just naming my favorite frogs right now.
My
um,
favorite frog is the bullfrog.
oh, okay, okay, cool. You
Because
like the
it's
big ones.
bullish. So that was a bad
I
joke.
hope that's actually true and not a joke that you just made. Um,
It's half and half,
half and half.
but that's
Perfect.
okay.
But yeah, and then I guess moving forward, I want to introduce Anyrand too. If you can tell us a little bit about, I guess, what it is and how it works behind the scenes.
Yeah, of course. Yeah, Anyrand is actually a service that we have been working on. There was actually a lot of work behind it before we even thought about like the whole Anyrand service. Basically, we needed some sort of some form of VRF, verifiable random function, for some apps we were working on. And we found that it wasn't available on a lot of chains, and especially Scroll is highly deterministic. There's really no entropy on chain, and so we were looking at some ways how we could bring entropy on chain. And there's this project called DRAND, which is a way to generate verifiable random numbers using BLS signatures. So how it works is a bunch of nodes run the DRAM software, and they continuously produce verifiable random numbers through signing threshold BLS signatures. Now, uh, what we worked on was we enabled BLS on the BN254 curve. So before it's running on the BLS 12381 curve, which is not efficiently verifiable on the EVM, let's say. So we changed it to use a curve that's efficient on EVM, and then basically made it available to be verified on any EVM. And the Anyrand service is just a service on top of that. Sorry if you're hearing the airplane.
No worries.
Um, yeah, so it's just a service where if you have a contract that needs randomness, you can request randomness from our Anyrand contract, and the Anyrand contract will automatically compute a DRAND beacon round. I'm sorry if I'm throwing a lot of words around, but there are a lot of terms. It'll compute a beacon round, and that beacon round can be taken from the DRAN network run by the League of Entropy, which is nodes consisting of Cloudflare, Ethereum Foundation, and very reputable organizations. Um, so that runs off chain, and you can grab that signature from that particular round that's computed, and then it'll be posted back to your contract, into your callback in the contract, which we'll code up. Um, and it'll deliver the randomness using that signature. I hope that was clear. There's a lot of moving parts. in the coding walkthrough. I
Yes.
hope it becomes more clear.
Yeah. I think I did want to ask like one question about, you mentioned beacon rounds, if you can explain that a little bit more in
Right.
depth.
So the DRAND network, run by the League of Entropy, it continuously produces random beacons. We call them random beacons. Each round is produced every 3 seconds. And each round produces like this random beacon, right? So a random beacon is basically it's a signature that's produced by a threshold of the network, and that signature is used as the entropy to feed into a hash function. In this case, Ketchak 256, and that is where the randomness is derived from. So beacon rounds produce randomness, verifiable randomness.
I see. And then this was something I was actually thinking about the other day, and I apologize if this is a naive question. Is randomness like, I guess, is it before all of this, like randomness is not verifiable?
Yeah, it's actually a really good question.
Okay, yes.
No, it's a really good question because I think it's very, should I say, misunderstood or not really well understood by a lot of people. I mean, I think when people hear randomness, they have like they assume that they know what randomness is. Like, yeah, I know what randomness is. It's just something random that happens. But there's a lot that goes into it, right? When you start getting down to like the maths of it and the like even the philosophy of it. So you can have something like you can get a random number out of like a lot of things, like noise. Like you have a microphone and then you just record some noise and then you encode that noise somehow into some numbers. That's randomness, right? And that's like you can use that number to you turn it into like a coin flip. You like if you modulo 2, if it's even, it's heads. If it's odd, it's tails. Like that's how you can transform randomness into something useful. But that's not verifiable, right? Because how do you verify that? Like if you ask me to do that to record some noise, and then I'll give you the number. How do you know that I didn't change the number? How do you know that that is the number that comes from that microphone that I recorded? There's no way of verifying that. So verifiable randomness is actually a different approach than that. Instead of using something like atmospheric noise or sound, or like Cloudflare uses like videos of lava lamps, for example, to generate randomness, which is really cool, but not verifiable, right? So instead of doing that approach, verifiable randomness takes more of like a mathematical approach through cryptography. So you know how we have digital signatures. So for example, like our Ethereum wallet, we have a public key, which is our address. That's the public key that everybody knows. And to sign transactions, we actually produce a signature using our private key, right? We don't reveal our private key, but that signature, we can actually verify that's a signature that came from this specific address. So you know that that's coming from me. So it's like that's the verifiability of it. Now there's some problems with the ECDSA implementation. Well, yeah, the ECDSA signature scheme is not deterministic, so there's some randomness element into it. I don't want to get into it because it's going to get confusing. But basically, the digital signature scheme that's used for your wallet, your Ethereum wallet, is not sufficient for VRF. So we're using another signature scheme called BLS, which does produce deterministic signatures. So what does that mean? Is that with your private key, if you sign a specific message, it's always going to produce a specific signature and nothing else. And so you can verify that that signature comes from this public key, and you could not manipulate it in any way. And because signatures are supposed to be unpredictable, right? That's what makes them secure. Because if you could predict people's signatures, then we'd all be losing our money in our wallets, right? The system just wouldn't work. So now we have that system. it produces a deterministic signature. That signature is unpredictable. We can feed that signature into a hash function. In mathematics, I think they call that like the random oracle. So something like Ketchak 256 is like an approximation of a random oracle, which means that one of the things is that it outputs a uniform random number in the domain of 0 inclusive to 2 to the power of 256 exclusive. And with that, number at the end of it, that's the verifiable random number that we can use to do fun stuff with. Make coin flips, do lotteries, do sortition in governance. Anything you can think of that requires some unpredictability.
A follow-up question, I guess, because I do think it's interesting that this is an initiative brought with like Cloudflare and like these kind of Web2 companies as well. And maybe this is a bit of cynicism of like, I can understand why people in like blockchain and crypto care about verifiable randomness, right? But what is the motivation for these external parties to like go through the extra work of making it verifiable?
Yeah, so that's actually a very good question. So what things like DRAND and things that deal with VRFs, like verifiable random functions, they're worried about public randomness. So randomness that you want to be verifiable by the public, and random numbers that are, it's a random number that's intended to be used for something public. And I don't have an example off the top of my head that Cloudflare would use it for, but I'm blacking out. Yeah, but of course, blockchains are very interested in this stuff because we really care about transparency and verifiability. But there's many use cases outside of Web3 to have verifiable public randomness, as opposed to private randomness.
Yeah, okay. No worries. I was just curious if you know. I mean, like I know you're not you don't work for those companies, so you don't represent them. But
Yeah, I mean it's actually a collaboration, it's not just Cloudflare, like it's Cloudflare, which they do Web3 stuff, like they're interested in that stuff. But it's a collaboration with them, Protocol Labs, the EF runs a node in the League of Entropy, lots of other reputable Web3 kind of organizations.
Yeah. No, very cool. I mean, the more I learn about it, it's like this random like rabbit hole, I guess, because we had our first full conversation last week. If you guys don't know, I guess check out. We did kind of just like a general overview about like randomness. And then my mind has been somewhat boggled since then. So, but yeah, I think, but the heart of this really is like, actually diving into the code. So I guess for application developers out there, how do we leverage this in our apps? I know you have like a code sample that we can do some live coding together, and fingers crossed everything works.
Yeah, let's hope everything works.
Yeah.
Let's hope we don't have the curse of the live demo as usual. But yeah, I'm gonna go through the coding up a simple coin flip contract. We're gonna do an on-chain coin flip. In the end, maybe we can deploy it, and then you can pick heads or tails, and then we'll see who wins.
Oh no! Do I get a prize for winning?
Oh yeah, we can. What kind of prizes are we playing with here?
I don't know. The thing is, like, I hate actually doing this because I don't want to lose.
We'll just code and we'll play, and then it's just like if you win, it's your lucky day.
Yeah, I can tell everyone I won today. Cool. Yeah. So I guess if you want to go ahead and like pull up your
let me pull it up.
Okay. Cool. Yes.
My screen's visible.
Mm-hmm.
Cool. Yeah. Well, let's begin. So I am on the docs.anyrand.com page, and I'm at the quick start page, which has very useful information on getting started really quickly on how to use the Anyrand VRF. So we'll go ahead and copy some of these interfaces that we will need. in our contract, and you can actually just copy that like that. Very simple. And we also need the Anyrand interface, which is the interface of the Anyrand coordinator. And once we have those, we can actually start coding. Yeah, so this just shows really how to receive randomness from your contract. You have to implement this interface, and how to request randomness from your contract. So you have to call some functions on this interface. And there's an example here. So we'll actually copy that example, and we'll create a new coin flip contract. Right. We'll just delete some of this stuff first, so we can start from scratch. And yeah, let's delete this stuff so we can show how everything works and why we write them that way. So yeah, let's name this coin flip now. With a coin flip, let's start with like a coin flip result, right? So when you flip a coin, you either get heads or you get tails, right? But there's also like initial state where it's like you don't know what the result is yet, right? Because you got to wait for the for the results of the VRF. And yeah, so VRF will actually give you the request ID when you request randomness. So we can actually record the state of the result here. So let's call them results. So this will be a mapping between the request ID of the VRF to the actual result, right? So coin flip results, and this will make sense a bit later. We have the Anyrand address here, which is important because, well, the contract needs to know where is the Anyrand coordinator, right? So today we're using Scroll Sepolia, and if you go to the docs and you go to supported networks, you can actually find the address of the Anyrand contract on Sepolia that we need to use for later. We need that when we deploy. But anyway, I put that in the constructor so that we can specify the address of Anyrand in the constructor when we deploy. Okay, now let's try to code the actual logic, right? Let's delete this, and let's say that we want to name the function flip, and this is to flip a coin. And this is going to request a random number from Anyrand. And then later on, Anyrand will fulfill the random number on this callback. So first we will implement actually requesting the random number. So if we go to the Anyrand interface, we can find the request randomness function here. And then if we implement that here, so that's the Anyrand, and then we're gonna, yep. This actually returns the request ID. So we can go request ID there. And what's important here is we have a deadline. So what is the deadline? It's kind of a bad name, but the deadline is basically which round, it determines which round should be selected in the future from the DRAN network where the randomness should be derived from. So it's always sometime in the future. There's a minimum of 3 seconds, which is the single period of the beacon rounds. They get produced every 3 seconds, so that's the minimum. Here we're just going to do 10 seconds because we don't want to wait too long. And the callback gas limit, so that is the amount of gas that your function here will require. You need to specify that because the Anyrand coordinator will only use that amount of gas to call your callback. So if it's not enough, then it'll revert. So it's up to you to kind of figure out what that is. It's always good to leave a little bit of overhead.
Can I interrupt here? We have
Yeah, sure, yeah.
from the audience, if you can zoom in a bit.
Oh, yeah, absolutely.
Please.
Is
And then
that
also,
good?
I guess well, okay. I'll say it's good for me. I'll let you know if the comment comes in and says bigger. I wanted to talk a little bit more about the deadline. I was just curious, like,
Yes.
how do you just, I guess, do you choose a random number? How does the number of seconds affect, is like, why recommend 10 versus like 3 or 5?
Yeah, it's really up to you and what you're comfortable with. There is a maximum deadline you can see in the configuration on the docs, but it's about how much security you're comfortable with, right? So maybe you want to wait like, I don't know, 30 minutes to get the round. It just needs to be sometime in the future. Maybe you don't trust the sequencer to be posting the correct timestamps or something like that. There's a various kind of things that you might be concerned with that may influence your choice for how many seconds or how many minutes into the future that you want to wait for the random number. But it's always in the future. That's the important thing.
Okay, cool.
Yeah. So here it's just like it's blocked timestamp plus 10 seconds. So it's when the flip transaction is submitted plus 10 seconds, and then after that, the nearest round is used to actually fulfill the randomness. Right. So there's one more thing we need to do here to be able to request randomness, is that we need to pay for the gas because, well, we need to be able to cover gas. So the way we do that is we need to get the request price, and we need to call Anyrand again here. And so we have this. This is the return values. We don't really care about this one. Doesn't like something. Oh, yes. So we also need to specify the gas limit here because, well, we need to calculate the price to have this callback gas. But we can make this neater so we're not duplicating stuff. We can make that into a variable. We can put that at the top as well, make it a constant. So yeah, we have that. And basically we have our request ID here. And we should probably, we should emit an event. So request it. And then index, we should emit the request ID so that we can see in the logs which request ID we got from the VRF to identify our coin flip later. And then after that, we can actually implement our receive randomness callback. And what's important here is that you only allow the Anyrand contract to call this callback, because otherwise anybody can just call the contract, and it's kind of useless. We can do that, and you can be extra safe here, and you can go like make sure the request ID, the result of the request ID is like still none, but this is actually not possible because the Anyrand contract prevents the fulfiller from fulfilling twice. But we can be extra defensive here. Never hurts. And then we need to we get the random word here. This is the verifiable random number. It's already been verified on the Anyrand contract through cryptography. but we need to turn this random number, which has a range from 0 to 2 to the power of 256, into some number we can use for the coin flip, right? So a coin flip is binary. It's either heads or tails, right? So we can actually calculate the result by picking, if the random word is even, we can say it's heads, for example, and then if it's odd, then it's tails. Does that make sense?
Yep.
Cool. So now that we have the results, we can actually assign that to the results of the request ID. And then we basically have the result of the coin flip, right? And it's probably good to also emit an event here. Let's emit the request ID. Also, let's emit the results and maybe even the random word. Now we gotta put that event in as well. Make this index for convenience. We can use this as well. Anyway, this one is also, yeah. Okay. Right, so we actually need to fix this, and this should also implement this. What do we have here? Oh yeah, we forgot to actually supply the gas. So this is how we pay for the gas. We transfer the price that's calculated for the request here to the request randomness function. Now, of course, you need ETH in the contract to pay for this total price, right? Because we're passing ETH value. So we can either make this payable and supply ETH when we call the function, or we can just make it so that we can load the contract up beforehand with ETH, and then that's how it'll pay for the VRFs. You can use either function; it's very flexible. And I think we're finished. I think we can deploy. We can try to deploy it. Hopefully, I didn't miss anything. So that's something I deployed before. Yeah, this might take a minute or so. So, did you have any questions? Was anything unclear?
No, I feel like this is really straightforward, which is super good.
Yeah, it made it like as simple as possible, just
Yeah.
to kind of demonstrate how easy it is to use VRF.
Are you? Oh yeah. Okay. So you're deploying on Scroll Sepolia right now. Nice.
It's on Sepolia, yeah.
Yeah.
Hopefully, it's not like congested, or anything.
Oh, hopefully not. Or maybe hopefully that means we have activity on the network. Yeah. Or maybe I'll just blame it on the node provider. It's not our fault.
Which node provider am I using? I think I'm using the official, like the Scroll.
Yeah. So
Sepolia
the
does.
Scroll official one is provided by Anchor, I believe. But there's a few different like just public free ones that we can play around with. And then I guess if people wanted to do this locally, could they just fork Scroll?
Fork Scroll? Oh yeah.
Locally.
You mean like fork the network? Yeah. Absolutely.
Yeah. Okay.
Absolutely. Actually, I should probably just use this screen. So this is the deployed contract, and hopefully everything works. I don't know. I didn't test, but you should always test your contracts. Never YOLO deploy like me. I set a very bad example. Yeah, so you can see that was that's gonna be rejected. If you can see my frame wallet, I'm going to transfer some Scroll Sepolia Ether to the contract, so we can pay for the VRF, right? And let's hope that goes in pretty quick. To Gwei. I think that's confirmed. Yes, confirmed. So now hopefully we can do a coin flip. All right. Do you pick heads or tails?
I pick heads.
You pick heads? Okay.
Yes.
All right, so this is the flip transaction, and it's emitted a coin flip requested event that we wrote, and has a request ID of 13, right? So if we go back to the contract and we go to events, we should see that there's a coin flipped event, which is the event emitted in the callback that we wrote. And from here, we can actually see the results of it, right? And the result is 1. And if you remember, if we go back to our contract,
No, does that mean I lost?
what did you pick?
Oh, its index is at 0.
Yeah, because like
Okay.
0 is
Yeah, none.
uninitialized, right?
Okay,
So,
cool.
what did you pick again?
I picked heads.
You picked heads, so you won.
So I won. Okay. I was worried it was
Nice.
heads tails. I forgot there was the
No.
none. So good.
It's your lucky day.
Yay! Dang it! I should have bet something. I don't know. I could trade swag IRL. You guys have frog swag.
We have some swag, some merch, I think.
Yeah. Well, regardless, Scroll has a lot of really cool merch coming in. If anyone will be at DevCon, with like mechanical keyboard caps, and I'm getting on a tangent, but yeah, that's really cool. What was I gonna ask? Oh, this is completely unrelated to the demo, but the frame wallet, is that the new one from Paradigm, or I guess not old?
No.
No, because they came out with a development wallet a while back. I never got to play around with it, but Frame Wallet, it looked really cool, but I'm not familiar with it.
I swear by it. It's
Yeah.
the best wallet. Yeah.
Okay. I guess I'll look into. Is this purely for development, or is it like a normal?
No, it's not. It's not a development wallet. It's just
okay.
it's just a nice wallet. It works with like all my hardware wallets. It always works. Like it never fails. Like my ledges, my Trezors, my Lattice one, Grid Plus.
But there's not like a mobile version.
No, there isn't. It's just a desktop only. So on mobile, I'm still stuck with like MetaMask or whatever it is I'm using nowadays.
Okay. Wow. Sorry. For those of you who are like, I care about randomness. Why are you talking about this? I don't know.
It's okay. It's still related, right? It's
Still related. It was during the demo, which is good. Yeah, I don't know. I don't have any questions there. It's pretty simple. I guess someone did come in and ask, "What are you doing?" I don't remember when that came through.
So. I mean, I think we explained that before I started.
Yeah, so I guess what I'll say is this. I don't know exactly what you were asking about, but if you want context, scrub back to the beginning. If you're watching on like Twitter or LinkedIn, it'll be on our YouTube. So I think it's at Level Up in Web3 is the slug. So yeah, I think relatively straightforward. I learned a lot as always from you, Kevin. Thank you so much.
I hope so.
Yeah, no, I mean, I don't know. It's always such a joy. I know there's lag, so I'm gonna give it 10 seconds for anybody to come in and say, "Hey, I know exactly where I was asking what you were doing." But yeah, okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I guess that's it. Thank you so much again for joining, Kevin. I guess if people want to get, it's docs.anyrand.com. Is that what it is?
Yes, exactly.
That's where you can find the quick start. We also have some like tutorial guide on Level Up as well. So if you head over to levelup.xyz, we have some content there as well.
And we're going to have a challenge up soon.
Yes, we'll have a challenge up soon. So if you guys actually want to try and play around with the code, do it. So yeah. Thank you so much, Kevin. Thank you for your time.
Great.
I guess
Thanks for having me.
For joining live at a random work hour.